All right. Hi, everyone, and welcome to our second annual predictions event, where today we'll be discussing the decade ahead with Playground Global's general partners and our special guest, Reuters tech correspondent, Stephen Nellis. So I'm Allison. I do marketing here at Playground. And for those of you who are new, we're an early stage VC firm that focuses on emerging tech. So we, naturally spend a lot of time thinking about the future and the world we want to inhabit. So just quickly, a few housekeeping items to get out of the way in terms of how this will work. So this event is being recorded and it will be shared with everyone following the event, and it will be posted to YouTube in case folks on your teams miss it. We'll have a Q&A session following Stephen's interview with each partner, and he'll read the pre-submitted questions that you guys shared, and you'll also have the opportunity to ask partners questions kind of live that Steve will read off using the stage Q&A feature. So make sure and I'll look for that tab there. When submitting a question, you can indicate who the question is for, ideally. And we'll introduce those participants here in a minute that will give you a sense of how to address your questions. If you're experiencing a technical issue or you just kind of want to contact the organizers, use the event chat feature. And so with no further ado, let me introduce our panel today. So we have Peter Barrett here. He invests in next-gen compute, life sciences, and AI, and he's a Microsoft alum and inventor of the first widely used video codec. Jory Bell invests in advanced manufacturing, space tech, and life sciences, and in a prior life, he designed computers for Apple before founding mobile computing pioneer OQO. Matt Hershenson invests in hardware and compute, and in a previous life, he created the T-Mobile Sidekick. Bruce invests in automation and logistics and ag tech. He's very interested in sustainability. He's also the inventor of Apple's QuickTime. And we're really hoping that Laurie will be able to join us today. Laurie Yoler we're experiencing a few technical difficulties on the back end, but she invests in mobility, digital transformation, and cybersecurity. And she's also a founding board member and early investor at Tesla. And so last but not least, before I turn questions over to him, we're so lucky to have Steve Nellis joining us today. He's a tech correspondent at Reuters, and previously he was a reporter for The Information and the Pacific Coast Business Times. He reports a lot on semiconductors and is just really knowledgeable kind of across the tech ecosystem. So he's a great partner for us today to facilitate a really fascinating discussion, hopefully. So with that, I'll turn it over to Steve.
Thank you, Allison. Stephen Nellis here with Reuters. As Allison says, I cover semiconductors, hardware, and other hard and deep tech topics. So I'm really, really excited today. Thank you to all the folks at Playground for having me. And the reason I'm so excited is that I've been writing about tech for about 15 years, and to be honest, it's become a bit of a trying time in the technology world. There's been a lot of businesses that have gotten a lot of money and a lot of attention, and you sometimes wonder, where is the technology really in this business? And many of them are doing interesting things, but some of them we really do have to wonder what they're really applying all that talent towards. So what I'm excited about today is, if you have been sitting at your desk for the past 18 months and thinking, why am I just grinding out the best years of my working life, optimizing for the next click, or iterating on some widget, and I'm not even sure if anybody really needs this thing in their life, but I'm spending all my time on it. Well, this is your opportunity to hear more and learn more about some really fascinating fundamental technology that is aiming to put a dent in the universe on some of humanity's biggest problems. And I think one of the major themes that we want to talk about today is climate and decarbonization. But I think before that, Peter, a good way to get into this would be to talk about what you guys mean when you say Fulcrum technologies. So, unlike a lot of VCs who are out there investing in the next quote-unquote rocket ship that's really just a SaaS company that rightfully is going to improve some small part of the business process. We all don't want software that sucks. There's nothing wrong with that. But you guys are funding actual rocket ship factories and going after big problems. But the question is, how do you delineate that from trying to boil the ocean on things that are really still science projects? And just what do you mean by a Fulcrum technology, and how do you find them?
Yeah, thanks, Steve. So a Fulcrum technology is a focused technology that can be leveraged up into a transformational company or industry, right? And that they often have something to do with the physical world, things like, quantum computation that, if you can build a large-scale fault-tolerant quantum machine, you're then in a position to use that to generate a whole bunch of other Fulcrum technologies, materials, catalysts, drugs, chemistries. It's the things that have impact beyond their intrinsic technology, and gives us the nexus of opportunity to invest in companies that become possible once those technologies exist. And there's a lot of examples of that in and around decarbonization, whether that's investing in hydrogen infrastructure that allows hydrogen-powered aviation or transport to become a real thing, in technologies like superconductors that we have, but we don't understand how they work, and to be able to design and engineer superconductors that beget all kinds of things that, whether power transmission, storage, motors, fusion, all those things become possible once you invest in the fulcrum of those new materials. We don't have to make batteries out of lithium. We don't have to make beef out of cows. We don't have to make solar panels out of silicon, right? All of those are examples of things that, as a deep tech Series A investor, we can, create these fulcrums that enable us to invest in the diaspora that happens afterwards, but also really have an impact with those, leveraging out those early investment dollars.
Yeah. Well, one thing I'm curious about there is a lot of those categories you talked about, superconductors, right? To work well and do what they need to do, they need to go into the grid, which is where a shockingly huge amount of our energy basically just gets wasted moving it around. All those things you have to operate through bigger systems and things like that. So, where does your work kind of begin and end, and where does the broader work of infrastructure providers, hydrogen infrastructure is another great good question for this. Where's your work begin, and what are you looking to do in terms of kicking off a broader change in infrastructure? Yeah, look,
I think what we're really good at is getting it past the threshold of undeniability, right? Mm-hmm. You can argue you'll never fly planes on hydrogen, but if there is a plane going overhead flying on hydrogen, that's hard to argue with. We're in a position to make these things tangible and real, and you can argue that you can't build a 1,000,000-qubit quantum computer, but the guys across the street are doing precisely that. So our role is really to take these, the things that are, proven science, reduce them to practice with engineering, and attract the capital to make them impossible to ignore. Mm-hmm. And there are some big dynamics with things like the grid, things at global scale, which it's a multi-step process in order to make that transition. But the first step is making sure that it's not a question of whether we can or not. It's mm-hmm. just a question of how we're going to pay for it, in what order, and the will to carpet the earth with these inventions as we create them.
Yeah. Well, I wanted to turn to Matt and actually expand on this a little bit. So a lot of these technologies, as Peter was mentioning, are really going to be driven by computing. And I'm wondering if you can help us unpack that a little bit and understand why that is. So, we take a few examples, battery chemistries, right? These are things that in some cases have been known for decades. Or frankly, in things like farming, how we make ammonia goes back almost a full century, and it's basically like we needed to blow some stuff up around World War I. We came up with a process for it. So how does computing, Matt, play into this? Why is it so important to keep focusing on that? Because I think a lot of people read the headlines about this company and that company trying to make a faster chip here and there, but I don't know if folks have kind of fully absorbed what it's going to mean to be able to do stuff at quantum scale and essentially not have to root around in the dark anymore when we can, do some things more systematically.
Sure. So that's a great question. And in the context of quantum computing, what's important to understand is that to date, the way that computers have assisted, and there's been substantial assistance in some realms for computer modeling, the modeling is not of very high fidelity. just because the ability in a quantum machine to not really to almost replicate, if you will, the physical interactions at a very high degree of fidelity is only practical in a quantum computer. So the kinds of things, and I think Peter touched on that, you brought up some as well, in terms of battery chemistries, large molecule for drug development, catalyst development, those kinds of things. In a quantum, in a practically scaled quantum computer, the models for those are incredibly high fidelity. And so these kinds of physical processes where we've been sort of fumbling around in the dark with relatively good results to a certain extent, in certain realms. I mean, obviously, we live off of batteries and fertilizers and such in drug development. Progress has been made, but it really will be transformational to be able to model at the fidelity that quantum computing will make practical on a large scale. And you can already see that there are people who are, in anticipation of the availability of something like PsiQuantum's computer, are already planning for that arrival and thinking about what will be simulated. So the advances in batteries that can be enabled through that, and drug development and catalysts, just quantum's ability to faithfully model very high fidelity is something that classical computing just has not been able to approach in a meaningful way. And so I think you're going to see, as Peter described, it's kind of a fulcrum technology. Through the fundamental enablement that quantum provides, there's going to be a transformation across a broad range of industries, because our understanding of chemistry has been largely empirical, but has not been able to simulate actually in the physical level what's going on. And so once that exists, what can be done is kind of revolutionary in terms of the sorts of things that can be created then, once we really don't have to guess and experiment in quite such an iterative approach, but can really get high fidelity models that are working in a computational context and know what to do to improve these wide variety of agents and chemistries and those sorts of things. It's going to be transformational.
Yeah. Precision is always a big debate in computing, especially right now with so much AI work that's going on and people arguing, is this HPC system, how many flops is it at 64-bit versus 32-bit, et cetera, et cetera. Is there a good shorthand way or analogy to think about what the difference is between trying to do something like molecular chemistry with the fuzzier resolution that we have now and what it would look like, in sort of full tack sharp relief when we have quantum? I mean, any ways to help people kind of understand what that difference is? Because I think, folks may need a little help understanding just the degree of compute required to really follow every law of physics about this way the molecules are going to tightly pack together down to the atomic and subatomic level.
Well, I think you certainly could say, I think an analogy is really powerful for understanding things. And I think that you can imagine sort of the world before spreadsheets and just think about what would be the complexity that you could track in a business model or something along those lines, or any sort of complex organization in terms of tracking the performance of, say, a bunch of players on a team and trying to calculate team averages and individual averages across a season and across a set of situations. There are any number of things where if you had to do it by hand, I mean, it just would not be scalable to a practical level. And I think with the advent of quantum computing, the ability for the kind of scaled machine that PsiQuantum will create to model is, again, it's as the calculator moved to the spreadsheet, it's similarly, if not more revolutionary transformation to be able to model things at such a degree of fidelity that insights that, again, previously just with a calculator pecking away you would have never gotten to. The same thing will be true of the kinds of simulations, molecular and chemical, that will be enabled by quantum computing. So it's a quantum, not to use, but it is a quantum leap, right? I mean, it is transformational in terms of what what's going to wind up happening. It will be at the next level in terms of what we can know about what's going on in these systems. And so the kinds of benefits that it will deliver are going to be, there will be a distinct difference in terms of what was possible before and after that level of modeling came about.
Yeah, I mean, if I may, these things differ by kind and not degree, right? That there are problems that we want answers to that a classical computer that used every atom on Earth and ran for the lifetime in the universe would still not come up with an answer that was useful. And that for any non-trivial chemistry, we don't know how to do chemistry. We guess everything we have, all the catalysts, all the drugs, they're guessed at. We have no idea how they work. And no amount of classical simulation or classical computation will change that. Quantum computers are quantum systems that can simulate quantum systems. It's the only way you can do it. And there is a list of impossible questions we want to answer that no classical method will ever get us to.
And people are lining up to partner and answer those questions because they know what the questions are. It's just, as I said, there's not enough time out there to do it on a quantum system. Sorry, on a classical system because it's impractical.
Yeah. Well, I want to move upward a little bit from those questions to space. I'm gonna go back down to Matt's window and talk with Jory there. Jory, what are the big opportunities in space that you guys see as commercial opportunities, and how much do they depend on getting the cost down, and then what needs to be worked out to make space commercially viable for making money, specifically property rights? I mean, there's some international treaties on space right now, but what's the business environment going to look like up there? But first, what are the things that get you excited about it and things that can be done there?
Well, I mean, I think it's still pretty early days, which is exciting. I think there's been a transition from huge only nation state level players to private companies partnered with nation states to private companies going it alone, and so now I think you're in an era where the technologies have transitioned to a maturity point, and there's financial support for starting new companies that are not primarily reliant on the government and are looking to support a business case. And I think so. Launch has been key. Obviously, SpaceX has been transformative there, and the SpaceX competitors as well. And we are an investor in a launch company, Relativity Space, which is the company that's building the factory to build the rocket. So they're looking to 3D print not just the engines, but the entire rocket structure itself, which has a bunch of applications. So that's one big one. I think on the combination of lower cost, higher frequency launch has enabled a bunch of applications in satellites in both geostationary orbit, but also medium Earth and low Earth orbit now. And those are coupled with the reduced cost and increased performance in things like semiconductors and batteries and solar cells that are coming from terrestrial applications. And now you, instead of having to spend billions of dollars on a single kind of exquisite 20 to 30 year thing, you can have a constellation with tens or hundreds or even thousands of much lower cost, much higher performance satellites that may only last for 2 to 5 years, but you can generate a huge amount of value in either Earth observation, communications, all sorts of applications, most of which are focused on kind of the needs here on Earth at the moment. I think in terms of government regulation, at this point, I think the most pressing need is kind of regulation and clarity, and kind of really has to be international clarity on how to deal with orbital debris and debris mitigation. That's something where, as we're now having, I think SpaceX and with their Starlink constellation has launched more satellites right now than were previously launched or something. It's like a huge number. And if there is a collision in space, as we saw recently where Russia tested an anti-satellite weapon against one of their defunct satellites, creates a huge debris field. It threatened the ISS that's there for years, decades, or sometimes forever, depending on where that happens. And right now, there's no requirement or really kind of strong pressure for any one company who's launching satellites to somehow figure out how to address that if their satellite dies or if something happens to it. And so I think, and on our end, we've looked at really interesting companies like Leo Labs, which does radar tracking of debris, like Astroscale and others that are doing debris cleanup. But it's challenging as there's no requirement for people who would be responsible for an accident to actually clean up after that accident. So in orbital planes, as it were, that seems like the critical thing. I think it's really interesting now to see the super early transition to there being more kind of actual commercial engagement beyond Earth orbit, starting with kind of various moon projects. And I think early on, a lot of that is going to be less about government regulation and property rights than the government being kind of the first and best customer for some of these things to build that out. I do think eventually you will have a transition where you're going to care about things like mining rights on the moon or on asteroids or that sort of thing. But I think the challenge there is going to be that those are going to have to be international. Like certainly, we've seen in the last decade, and especially in the last year, where China now, for the first year, surpassed the U.S. in the number of satellite launches this year, and has a space station, has done a Mars rover, has done has done a far side moon landing, and so I think that the challenge is going to be to kind of go beyond a lot of the kind of competitive aspects in the politics here on Earth and find out how we can not replicate those beyond our sphere.
Yeah. Well, if anybody in the audience has a pitch for a space Roomba, make sure you get in touch with the Playground guys. I'm sure they'll want to hear from you. So I want to bring us back down a little bit to all the way to the ground and talk a little bit about agriculture. And until we get off Earth, how we're going to feed all the folks that we do have and will have. So Bruce, I'm really I want to pick your brain a little bit about how do we feed these many billions of folks when we're not going to have any more land. A little bit of new land is going to be made by maybe climate change in some places, but taken away in other places. So excluding volcanoes, we probably have about as much as we're going to get on the land side. And frankly, even feeding the number of people we have, we see issues with soil depletion. Like we're all in California right now. Our Central Valley here has some of the best soil in the world. It's being what's been put there over millennia is being depleted on the order of decades. So clearly that's not going to be able to continue even with the number of people we have. Definitely can't feed more than that. How do we do it? I know you guys have some interesting robotics plays and things there. But in the big scheme of things, how do we get more productivity out of it in a sustainable way?
No, I think you're absolutely right, Stephen. I mean, look, we're not going to have any more arable land. We can't cut down more forests. And climate change may create some opportunities in new locations where, there's no longer snow or ice, but it's going to hurt us in existing locations as well. So we kind of have what we have kind of in best case. And it really comes down to efficiency and productivity. How can we make the most out of what we have? And we definitely, can't economically or even ethically, afford to dump more chemicals on those fields in an attempt to get more yield out of them. In fact, fundamentally, we need to substantially think about how do we decrease the chemical input side of agriculture so that we don't have the runoff and the fouling of our oceans and waterways. And I think the only obvious approach is to move from a field by field type of agriculture that we've been able to get away from to date, and really move to a precision agriculture approach, which is really plant by plant basis, focused on minimizing inputs and really maximizing outputs. Fortunately, the sensing technologies like multispectral imaging and computer vision are really there to take advantage of, and can provide the farmers with the rich data sets that they need to power the farm and what eventually will be the farm OS that helps keep track of every plant and its needs. And as you mentioned, robotic automation is going to be there to provide the tools, to care for each plant, on an individual basis. I mean, fundamentally, Stephen, agriculture needs to move from to become a model of sustainability and away from, what today is to some degree part of climate change.
Mm-hmm. Well, just to tack one interesting follow-up on this, I'm wondering if you could talk a little bit about the business models. And, I don't know exactly who's in our audience here, but modern farming is already driven by technology. There's already huge capital investments. I mean, I have a cousin who's spent lots of time basically learning how to run a giant automated John Deere combine that is on the cheap end, probably $500,000 piece of capital equipment. So there's already an embrace of technology and a willingness to, or an understanding that sometimes you need a big complex piece of capital equipment. One of the things I'm struck by was something you said as we're preparing for this, that one of the robotic weeding tractor companies that you guys are invested in, you mentioned that thing basically, it prints money. It's very expensive, but it prints money. So talk a little bit about the business and where the capital will come from there, because agriculture is heavily subsidized, at least in this country, and there are heavy capital requirements and stuff like that. What are your constraints in terms of business model, in terms of, I can make a $500,000 piece of capital equipment because people understand how to patronize that.
Yeah, I mean, I think that today, as the technology is still nascent, the models we've seen embraced and most successful are really, farming as a service, technology as a service. Come in, provide a service, get paid for it, and have it, not have the farmers to have to bet on a technology and pick winners and losers. Have them, get their needs met. Provide better yields and share in the upside. All farmers are from the show me state, right? Results matter. I think where we apply the technology and it's demonstrable and can deliver on the promise, I think the economics are there, right? I mean the cash flows in the food industry are incredible. You just have to be able to move the needle. You really have to be able to, create a benefit for the farmers, and in return, it's no problem getting paid. Now, as you said, farmers aren't fundamentally afraid of capital expense, but I don't think we should put the risk of new technologies on farmers. I think we need to take those on our backs and prove that they're ready for prime time.
Yeah, great. Well, thank you, Bruce. So I want to move now into taking some audience questions. So. Folks, if you want to submit questions, I think we've got folks who are going to pass them to me here backstage, but we've got some pre-submitted questions, and I'm going to hop over and I'm going to toss a couple of those at our panel members here. Before we do that, though, just a quick check. I don't think we've gotten Laurie. Yes, I don't think we've got her on yet, so apologies about that, and we'll just move on into some audience questions. And so this is a good one. This is from Anumi Sharma, no company name given. But I like this one because, I spend a lot of time covering consumer electronics, and I am curious to hear what you guys are going to think of this question. So the question is, AR and VR seems to be in sort of a stagnant state for the last few decades in terms of popularity and public adoption. Do you think that will change in the coming decade, or will we see a similar, extremely slow-paced growth in innovation and mass acceptance toward the field? So I will let whoever wants to go first on that one, because I'm curious too. I've wondered, I've tried almost every headset. It's really interesting. There seems to be still a few key technologies that are not there, and display drivers, etc. But even then, I'm wondering, what's this useful for? How does this empower humanity? What's the use? So, who'd like to go first?
I'll have a crack. Right. Yeah. I mean, so what? As a reformed investor in the space, look, I think. So there are some biomechanical problems that are getting solved, right? So Vergence has been a big one. If you have live field displays, you can make something that doesn't make you feel uncomfortable after 10 minutes, which has been a constraint. The thing still goes in your head. It's still sort of not a natural thing to do. And it's fun on the consumer space for 10 minutes at a time, once a week. Try it once, try it twice, never try it again. I do think it has real applications in industry. If you're trying to service a GE engine, if you're trying to take a pancreas out, I think that there are certainly very valid applications for, for hands-free VR interaction, and I applaud that. But the thing that really makes my skin crawl is, after being on Zoom for 2 years, the idea that I would want to spend any time with Mark Zuckerberg in the metaverse is quite beyond me. That sounds like a appalling idea. It's, those ideas are 40 years old. I think there's a reason why we have not gone to the trouble of making that technology really work, because I would much rather spend time away from the uncanny valley with my fellows in 3 dimensions, doing things that humans have evolved to do over the last 100,000 years. And the idea of virtual Mark Zuckerberg bumping into me in the metaverse just makes my skin crawl.
Bruce, Joy, Matt, anything from your end there?
I mean, I do think that, we've all learned from the pandemic that utility to being able to connect across distance. And, I look forward to a world where we can do that. I prefer not to have something on my head and not something on your head when we're interacting naturally at a distance. And I'm still looking forward to people who want to solve that problem for real.
Yeah, and I think interfaces evolve over time. Obviously, the penetration of smartphones certainly shows that people are very interested in something that's much more portable than a laptop to have with them, and the utility is certainly worth it there. Watches are nowhere near as popular, but obviously have emerged smartwatches as a category as well. I'm not sure that there's the same kind of killer use case, apart from some of the vertical industrial kind of applications that Peter mentioned, some of those of which are very, very compelling. But to replace laptops in an office setting, to replace smartphones in a lot of mobile settings, I don't think that it's all going to converge at that. I just, for the reasons that both Peter, as well as, I don't think that where it isn't the uniquely optimal solution for a particular problem, I just don't think that it's going to drive adoption in the way that it becomes the only thing that matters.
Although I think lumping in AR and VR together is tempting, but a bit of a red herring in that kind of AR is about you being in the world where you want and augmenting what you see in the world. And VR is really about withdrawing from the world and yourself more and more in an online only context. And I think, obviously Facebook / Meta is betting on the VR, and that's a signal enough that maybe that's not the direction to go. And I personally am more interested in the applications of AR in the real world as opposed to being in the so-called metaverse, which was itself coined as a dystopian hell in Neil Stephenson's book. So
I'm beginning to think you guys might not be huge fans of the metaverse. Thank you for that. And actually, before we leave that topic there, Joy, what do you think, are there any consumer experiences or non-enterprise or work experiences that you think are really ripe for AR? Because most of them seem, and these could even be hobbyists. Like, I would love to, get an AR instead of going buying the Chilton manual for my busted old car, just have it loaded into a set of goggles. That would be something I think a lot of folks would.
Well, I think gaming is the obvious kind of early application, and Pokemon Go showed that there is a huge demand for even very low fidelity, frustrating AR experiences. I personally am terrible with names, so I just love something that named people around me, so I could keep track of the folks that I enjoy interacting with, but don't necessarily have a good name recognition for.
But for those of us who briefly experienced Google Glass, even the most subtle wedges between humans, like having something on your head and knowing that you're not looking at them, you're trying to remember their name. It for me, and maybe I'm just a grumpy old man, but it stimulates my homicidal impulse. I mean, it's just It's just
Well, I'll get Elon's Neuralink, and then I can just see your name in my head, and you won't even know it, whether it's me or Elon. It would be great.
right. The answer is mate. If you don't know their name, just say, "Good to see you, mate." That's all you need to do. You don't need something on your head.
So for those among us who don't speak British English, that's usually friend or buddy or something like that. Great. Well, I want to move on. This is another question from the audience that was submitted ahead of the event. And please, if you're with us now, go ahead and send stuff in. Be happy to try to get to your questions. But this one is from Xingyang Xu from IEEE. And this one I think that Matt might be well suited for. What are some exciting investment areas and trends for AI and healthcare? And, I think, Matt, this is a very poignant one because we saw over the past, 18 months or so, rapid development of vaccines, very much assisted by computing. And we're not even to the quantum computing yet. So, what are really exciting things that we could have in healthcare and AI, with that added fidelity of quantum?
Yeah, and I think all of us probably have interesting views on that, and certainly want to make sure that's not just my answer. But in terms of some of the core capabilities of artificial intelligence, and sort of as I talked previously, what you can do with a calculator is not an adequate representation of how much more you can do with a spreadsheet. The level that AI has advanced to, and to be able to take in vast amounts of, say, diagnostic data, and, for instance, in terms of reading a number of diagnostic indications, or data, so chest X-rays, or being able to read and diagnose other kinds of diseases, being able to diagnose across population trends, for instance, the emergence of new strains of viruses, as we're seeing, and the ability to do drug development using artificial intelligence. Again, just the fact that so much more data can be brought into analyses. Now, it's not as transcendent as the kinds of things that quantum computing can do, but I think that there are a number of opportunities where artificial intelligence in medicine is really providing an impact already, and will in an increasing way. We have a company involved in drug development where AI is increasingly being applied, and so I think that across from diagnostics to drug development are sort of the leading edges of those kinds of things. We haven't invested in the diagnostics area in that regard, but we're always interested in seeing opportunities where that exists. So Peter and Jory may have additional thoughts on this as well.
Yeah. For us, I think one of the interesting things in kind of machine learning and so-called AI in drug discovery / drug development is that the initial batch of companies in the last kind of, call it decade, or maybe even just 5 years, that were funded doing AI drug development, were really focused on that very first stage of finding a hit and trying to find kind of more hits with maybe a slight improvement in the likelihood, in their quality, and the likelihood of them succeeding. But then really quickly, the drug development process would revert to artisanal methods for determining safety, for determining efficacy, and the whole thing through kind of clinical trials. And so I think what we're seeing and investing in is companies that are pushing technologies into deeper and deeper into that development process, so that you're not just increasing the number or quality of potential drugs at the very beginning of the funnel, you're using technology to either improve the outcome or speed up the development at each of those later stages, even to the clinical trial stage. And so I think that's just an accelerating trend, and there's a lot of exciting new work being done there.
Yeah. Great. Well, we've got some, did anybody else want to weigh in on that? We've got some audience questions now rolling in as well. Great. So I'd like to move into some of these from the audience. Here's one from Rocky Lynn that I think is a good one for Bruce. Do you see vertical farming overtaking traditional field-based approaches in terms of productivity and sustainability? So up rather than just out. Scale up or scale out? A question we've dealt with many times.
Yeah, I mean, I think that it's very difficult to compete with Mother Nature. The sun is an incredible resource. The soils are quite, prolific. The challenges we've seen in vertical farming are that, creating the light artificially is expensive. Controlling the HVAC is expensive. The land itself is expensive. It's typically an arbitrage against transportation. So, growing the leafy greens closer to the market, you can, if everything's grown in California, if you build it on the East Coast, you can save the time and the cost of the transportation. But it's very hard to win against soil and Mother Nature. And I haven't seen anybody who really can do that economically other than for simple examples of leafy greens, microgreens. And typically, even in doing that, those farmers benefit from selling directly to the grocers and with a consumer brand, so that there's no middleman involved in order for them to make a meager margin in order to pay for all that infrastructure in a major metro.
Yeah, it works in Iceland if you have geothermal power and it's dark 6 months of the year. It's great. Everywhere else doesn't make sense.
And then the sustainability side of it, burning a lot of electricity to make sunlight indoors. Sure, if you're using solar power to do that, it seems a little backwards.
Right. The plants have better productivity with that.
We're gonna put solar panels on the farmland in order to power the vertical farm in the city, so that it can be sustainable.
Understood. So here we've got another one. In Peter, I think maybe you should take this one. I think in our lead-up calls to this, you were somewhat passionate about some of these. This is from Deb Sehu, and it is, will NFTs bring real or meaningful step changes to existing ways of life? Or is the technology just a bubble? And I'd like you to just unpack it in a serious way. I know that you don't have that much patience for it, but I do think people really are, especially the younger folks among us, they're looking at this stuff and think there's a lot of money sloshing around. There must be something to this. But if you're talking to an earnest young person about this, what's your response to NFTs and maybe even applying that to some of the crypto technologies more broadly?
Yep. So how can I be polite about this? I think NFTs and Bitcoin are essentially Nero's fiddle. The world is literally on fire, and all this energy and all this capital is just in this Ponzi scheme, which has the carbon footprint of Argentina. The problem with NFTs is there's no barrier. I mean, there's setting aside the fact the underlying technology is actually entirely the wrong way of doing attestable computation or distributed ledgers. That it's designed on profligate use of energy at a time where we can't do that, and profligate use of computation at a time where we have better things for that to be doing. The thing that you're buying and selling is bragging rights or greater fool or things which I don't have any particular enthusiasm for, being done by a bunch of very clever young people who could be doing something worthwhile. So I just think it's an extraordinary waste of human capital and actual capital that could be deployed to other things. I do think that real technologies for doing attestable computation are super interesting and super investable, and we will likely do something in that space, but not to trade, coupons of greed and desire, but to attract capital into building things that are actually worthwhile and durable. And I like making money as much as the next guy. We like making big companies to return a bunch of money to our LPs and our families, but they're against something that doesn't make the world a shittier place. And I think
so I agree it's not for us. The only thing I would point out as a contrary take there to Peter is that I do think NFTs are an interesting approach to kind of solving the problem of scarcity in the internet when everything is inherently kind of free and accessible, and applying that to kind of creative arts in particular seems kind of a more interesting direction than trying to kind of wrestle money away from the nation states and do away with trust as an underlying aspect of our civilization or society. So in that sense, I think NFTs, are potentially a positive, but it is also a bubble in a like tulip-like bubble at the moment. So
Yeah, I know what you mean there. I grew up the son of a musician, so the early stages of NFTs where artists were making money, I was like, hey, well, okay, that's it's always good to see art make some money. Well, I want to switch gears a little bit and go back to quantum. An interesting question from Rob Christensen, I think, which is which industries are most likely to be impacted or disrupted by quantum computing advances in the next 10 or even 20 years? So who's going to get knocked off the throne? Who is IBM circa 1978? Right now with regard to quantum. And don't worry, we're recording everything. So
so it's not. I don't think it's zero sum. I actually think so. The quantum applications, the first quantum applications that are important are chemistry, materials, and therapeutics. Certainly, there are financial services and portfolio optimization, and that those will certainly happen very quickly. But the opportunities here are, the catalyst chemistries and materials that support our transition to carbon-free existence. That we're entering a phase where we need agency over our biology, and being able to design drugs instead of discover them is going to be incredibly important, to be able to design things where we don't have to be trapped indoors 2 years because of a virus that fits on an Atari cartridge. Those are the kinds of applications that are most important. And I think nobody has to go out of business in order for us to create new classes of therapeutics, to be able to create new chemistries for batteries and solar cells and for photofuels and so on. It's a great catalyst of creation of wealth. And when we look at our future funds, there will be a lot of focus on investing against that nexus of opportunity that gets created by that machine.
I would agree with that completely, as well as, Peter made a point, I think, at the beginning that's important, is companies that are in those industries that are forward-looking and will forge the right partnerships with emerging quantum computing companies and researchers, for other very important reasons, distribution networks, production means, those kinds of things. It doesn't mean that they're going to be out of business. If they embrace this change and are on the leading edge of transforming their businesses, they'll go through, substantial growth going forward. So it's not a death knell for them.
Well, unless they don't adopt quantum computing at the right time. And then if they're left behind in a classical computing world, they'll have inferior products and they will fade away. So sure. I think in all the sectors, anyone can choose to move along, and they're well positioned on both classical, and anyone who's using classical computation or even artisanal methods to bring that expertise to quantum applications. But within that time frame that he's talking about, 10 to 20 years for sure, anyone who doesn't adopt that in those sectors is going to be a dinosaur, and
yes.
That will be it.
But it's too early to report on their demise. Everybody has a chance.
Right. Yeah, and sorry, Bruce, you looked like you're...
No, I was just agreeing.
Yeah, I would say the one thing I hear the most is we're going to live in a heterogeneous world for a while, where people are doing both. And actually, one of the most interesting challenges is going to be how can you program to quantum and classical at the same time, and in a way that's fairly flexible and accommodates the world for
Peter. Peter's going to tell you that classical's not going away.
Yeah, classical's not going away, right?
Well, and that those aren't going to be. It's not going to be writing to both. It's writing the appropriate application to the appropriate substrate.
Right. Great.
I mean, one simple. Yeah.
There we go.
By O'Reilly.
Find an O'Reilly book, available on Amazon.
All right. Well, I want to start to wrap up with the audience questions here, and
everybody should have it.
Yes, we've plugged it.
Christmas is coming.
Christmas is coming.
Fits in the stocking.
So this is one that was submitted anonymously, but I think it's a good one to end on as we move toward the end here. And an attendee says, we're clearly going through a period of rapid change and uncertainty. What skills do you think entrepreneurs need to develop to realize future and current opportunities? So I like this question because so many of the things that you all are investing in, we're talking about today, are things where you're going to spend years of schooling developing the knowledge base in that science or technology, right? There's no boot camp, there's no coding boot camp for learning how to build qubits. But at the end of the day, pulling things over this transition from a science into a technology into a business is what we're talking about here today. And so I think this is a really interesting question. With everything that's gone on the past 18 months, and frankly, we could even lump that 4 years back. What are the key skills that are making people successful at pulling it through those phases into a business that, as Peter sort of put it, can't be ignored?
Well, so I think have the courage to reduce your life's work to practice, and make sure you partner with the right investors who understand your journey and can turn your transformative idea into a company that moves the needle.
Yeah.
And if you're in school, math, physics, biology, stick to the basics.
Yep.
Yeah.
I also think that, entrepreneurs need to not be afraid to dream big. We now where, there's a flight back to science and technology, and that, it really can change the world, and, we really need to build the world we want to live in. It's an incredible time, the amount of capital that exists in the marketplace that allows, things like, non-fungible tulips to get funded. Mm-hmm. Just imagine if you were trying to, raise real money to do something that was meaningful and durable and, really had an impact for generations.
Yeah, and those are the kind of entrepreneurs we want. We want people, we are singularly constructed to work with people who are solving hard problems, to appreciate the depth of their technology, the extent of their ambitions, and to partner deeply with them, because, the market will not continue on this tear forever, but we're there to stick with the companies who are doing transformational things through thick and thin, and to support those kinds of entrepreneurs, and to build things that we can all really be proud of when we look back and talk about how we really changed the world as a result of that persistence.
Yeah, and I want to go back to something, thank you for that, Matt. I wanted to go back to something that Jory said about stick to the basics on, math, physics, biology. One thing I would encourage people to think about is, first principles rather than tools. So a coding language is a tool. Computer science is a first principle. I think it's far, far too easy to let your tools and the ways in which you do work define how you think about it, and not go all the way back to the first principles in foundational sort of laws of physics or whatever other science field you're in. That really should be bounding the problem. As soon as you focus in on your tool, and in my own work, that means, get off of Twitter. Don't just email people. Don't just text people. Call them, meet them. That's you see far too much news coverage that's just people like posting stuff from Twitter. And it's like, sorry guys, that's not journalism. So think about your tools, and think about making sure that your tools aren't defining your thinking, because the second you do that, you've let whoever made the tool define the problem and the idea for you, and it's probably just going to end up with you giving more money to them.
And a lot of times, the kind of things we're investing in, the companies are building the tool to make
Yes.
the technology that they want, that then has a world-changing application. And so I think that comes from that, having your foundations and first principles and the basics, and then building from there.
Yes, and I think a lot of people, if you look at the history of Silicon Valley as a technology center, a lot of those original semiconductor firms, they not only had to figure out how to do the transistors, they had to fabricate them, right? Yep. The reason that it all sprung up there was a bunch of World War II era machine shops all over San Jose that could come up with these high precision pieces of metal for folks to make those. So yeah, that's super important. Like, think from the first principles and be ready to make your own tooling to make it happen. Great. Well, so we've got about 5 minutes left. I guess I just wanted to go and do like a bit of a quick lightning round with everybody, and just tell me one thing over the next decade that makes you get up out of bed and want to go to work, which these days may just mean, the other bedroom with the office in it. or it may be coming all the way into the office, but what is the thing that makes you still excited about technology, still excited about science and human potential, that makes you come to work every day excited about it? Bruce, let's start with you.
Well, I mean, obviously, just working with the next generation of entrepreneurs, is a privilege, and worth getting out of bed every day, because you learn something new every day, and it's a joy to be part of. I mean, I think that on a front, my personal plug these days is to think about ocean technologies, certainly in a sustainable way, but 2/3 of the planet is covered by the ocean. We talk about vertical farms. The challenges there are not the challenge you see in the ocean. The ocean has all the nutrients you need, has all the sunlight you need, and has all the globe area you need in order to do incredible things. Whether it's sequestering carbon, whether it's growing protein, whether it's sustainably mining minerals, or bringing taking wave power or wind power offtake. So lots of possibilities, and I think great ways to move our society forward.
Awesome. Matt, let's go to you next.
Well, certainly entrepreneurs power so much of this, so that's quite inspirational. I think that when you talk about sort of make sure that you aren't focused on the tool. I mean, tooling still matters, right? So I think that in the future of high performance computing, even quantum computing, things that are going on with lab automation and other kinds of realms, there's a level at which tooling will be built that will also enable a set of companies, enable a set of entrepreneurs. And part of what we're trying to build at Playground is essentially, tooling for entrepreneurs that then are building companies that are transforming these things. But as Bruce said, I think the number one thing is to work with great people who are doing really, really exciting things, and to help serve them to reach their full potential and the potential of the technologies that they've conceived, and bring those to life to transform the world as we know it.
Yeah. Joy, how about you?
Yeah, I mean, I think for me, it's the degree to which kind of the privileged position of partnering with deep tech entrepreneurs, scientific founders, allows and kind of, motivates, me to constantly be educating myself and engaged in just an ongoing kind of learning process that I think is just such a privilege. So.
And Peter, how about yourself?
And did I mention I like quantum computing? Look, I joke about it, but it is the most important technology since fire, and will be utterly transformative. But in the broader context of decarbonization, this decade will be extraordinarily important. But the more work we do in this area, the more we realize the opportunity to accelerate these technologies, with things like universal hydrogen and others, that there are some extraordinary short-term opportunities to reduce that science to practice and engineering, build giant companies in the process, and really change people's expectations about what's possible when. And there isn't a moment of the day that doesn't go by that I don't think about that. But one other thing I'll mention is being in a building with some of the best scientists and engineers on Earth who are producing novel work and reducing their life's work to practice to make these extraordinary transformative companies. Gives me as an engineer a guilty pleasure of going home every day knowing something I didn't know when I came to work. And that's the delight of finding this role. And I think we have, as a group, a unique opportunity to turn entrepreneurs into the leaders of extraordinary companies that will define our civilization.
Thank you, Peter. Well, I want to thank you, Peter, and all the rest of the panel. And all the folks at Playground Global for hosting this today and giving me the opportunity to moderate. And I want to thank everybody in the audience here as well. I hope that you learned something new today and are going to go back forth into the world more excited than ever about the potential of human ingenuity and knowledge to solve some of our most pressing problems, and really to do what the Playground Global folks are very excited about, which is to engineer the world that you want to live in. So you have the control, you have the knowledge, you have the power. If you need some money, you can come talk to these folks. They might be able to help you out with that. But really, I just hope everybody's excited about all these fields of technology and the potential difference they can make in not just our lives, but the lives of everybody else who's going to come after us on this tiny little pale blue dot. So thank you all so much for coming. Thanks to the entire panel, and hopefully we'll see you next year.
Thank you.
Thanks, Stephen.
Thanks, guys.